In this video we're going to talk about piecewise functions. Basically what a piecewise function is a function that is defined over different intervals with different equations. So a lot of times you'll see with two equations in one function, or maybe three. It could go up to maybe five or more. There's literally no boundary. So here's an example where we have a piecewise function f of x, where if x is greater than 4, so if x is greater than 4, we have the equation 3x minus 5. And if x is less than 4, or less than or equal to 4, I should say, the equation is going to be x squared. So let's just do a couple examples. So f of 7. So we have the function value at 7. Now we got to figure out which interval this fits into. Is this less than or equal to 4, or is it greater than 4? Well, naturally, it is greater than 4, so we're going to use the top equation. So 3 times rx minus 5, rx being 7. 21 minus 5 is 16. So f of 7 is equal to 16. Now f of 4 is equal to 4. So we're going to use this second equation. So whatever x is squared, which is 4. 4 squared is 16. So f of 4 is equal to 16. And last but not least, f of negative 3, is that bigger than 4, or is it less than or equal to? That is less than or equal to, so that's going to fit into the second equation. So that's negative 3 squared. Sorry for squeezing in there. Negative 3 squared is 9, so f of negative 3 is equal to 9. Here we're given a piecewise function, so it's a function with two equations inside it on different intervals, and it's asking us to graph it. So basically we're going to take this function, split it into two intervals, and pick some x's and plot them and do the best we can. So we have negative 3x plus 2 when x is less than or equal to 2. So let's pick some x values. So that are less than or equal to 2, so I'm going to pick negative 1, 0, 1, and 2. If I plug those in to the equation, negative 3 times negative 1 is 3, plus 2 is 5. If we plug in 0, we get 2. If we plug in 1, we get negative 1. If we plug in 2, we would get negative 6 plus 2, which is negative 4. Oops. Now I'm just going to plot those. We got negative 1, 5. Negative 1, 1, 2, 3, 4, 5. We have 0, 2, 0, 2. We have 1, negative 1. 2, negative 4. This is when x is less than or equal to 2. So this line is going to go to all the values that are less than. So it's going to go in that direction. And it's a closed circle because x is going to be equal to, or less than. So now we go to greater than 2. So let's pick values that are greater than 2. Let's say 3. So when x is 3, actually, you know what? Let's pick values that are going to make it easier on us. Since we got that fraction, let's pick numbers that would, if we multiply by a fraction, we get whole numbers. So let's try 4. So 4 times 1/2 is 2. 2 minus 4 is negative 2. Let's try 6. 3 minus 4 is negative 1. Let's try 8. And we get 0. So 4, negative 2. 1, 2, 3, 4. Negative 2. 6, negative 1. 8, 0. And if we were to plug in 2, we would get negative 3. And that's going to be an open circle because it's not equal to. It's just greater than. So now these are all the values that are greater than 2. So there we go. And there's our piecewise graph, our piecewise function graphed on the corner plane. After watching that video, you should be able to try, or at least try, these problems on page 290, numbers 12 to 15. just give it a try, and if you have any questions, ask during class. Other than that, enjoy your night.